All right, it's almost the time, so it's 3:59. We will start this webinar at 4. Are we excited? Are we waiting for that? We have some discussions about challenging questions. So you may take a piece of paper or several pieces of paper, pencil or a pen, and then try a note. A good note is always helpful. All right, it's 4 o'clock now. Hello, welcome back. So today we have our second half. Well, kickoff is a word we use in, say, sports games. So we have these two settings. We have one on Tuesday and the other one today. Well, now I want to ask you a question. Which one do you think is the hardest? Well, I prepared some. For time consideration, we couldn't cover all of those today. So I'll introduce some interesting questions and challenging questions from my perspective, such that to introduce why we want to do this, or say, how can we think of that in terms of mathematics? Well, different perspectives, different views are always helpful. Maybe some are even time-saving. Then we will get better and better in future study or future tests. How does it sound? Well, I'll wait for how about 10 seconds. You can make a free chat, and also you can type in whatever you like during this webinar. All right, so 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So now we will move along. All right, and you can talk about that. Let's see if I will cover some of the questions you like. Well, first, last time we want to mention the prediction. However, for prediction, it's not very easy. Well, what is the honor roll? What is the distinguished honor roll, the cutoff line? Well, first I put on the population, number of participants. Well, you may see there's a big drop around 2015 or 2016. However, for this year, maybe we can expect a little increase back up. Well, I study statistics. Do you want to make a guess why there's a big drop there? Well, sometimes reasons are complicated. Maybe there are social, maybe there are some technical issues or whatever. Well, up to what I know is that before 2015, a lot of countries in the world are holding AMC as well. However, around like 2016 to 2019, some countries don't have that. For example, back in China, some of the competitions were suspended for a year or two. That's why we have a big drop. This is a population for the worldwide students. However, this year we do know a lot of students in China will take it. Also in the United States. Well, we expect that, as we mentioned before. So a lot of students stay at home. So perhaps it is a good idea to study math, to take a contest. Well, back to the roll, back to all this cutoff lines. Honor roll, maybe we can see this. Well, for the past several years, we have the data official. On top, we have distinguished honor roll. It's in orange. And on bottom, we have this blue line that represents honor roll. Well, if comparing to the past 2 years, say comparing to 2019, comparing to 2018, we don't have some weird questions like there's no tool at this moment for our study. Like we need to think a lot more to create a tool by ourselves, where say we need to dig very much, get into very deep level in the course, then we can handle it. There's no such question this year. So potentially my prediction is around what we have for 2019, and perhaps it will get higher. Say we have 23 still for distinguished honor roll, and maybe 18 to 20, or say 19 to 21. Well, so far we don't have honor roll touching 20, so probably it's still around 18 to 20, this range, possibly. Well, as a statistics student myself, we know that actually a lot of information, a lot of reasons are behind. For example, what kind of students are taking it? If a lot of experts, say high-level, high-grade students are taking it, maybe the average will getting higher and higher. Or if a lot of newcomers, they want to give it a try. For example, some of you, like I'm in grade 3, grade 4, I want to give my first try here. You still have a lot of chances in the future years. So don't worry if you have like not very ideal score this year. If you do, you are super strong. So in this point, we have some contributions up and some contributions pulling it down a little. That means it's not very easy to predict. That's why it's going up and down all the years. All right, that's what we have so far. And you say, well, for some hard questions, we want to go really deep into the course, and can we help that? Of course, yes. Of course, yes. So here we have a little illustrations. For example, for this year, this 21, you have the chessboard. And I believe for maybe some students, they think this one is kind of a blur. Like, how can we start? This is possible. However, if we break it down, we will see actually it is a counting principle problem. So it refers to addition principle. Well, we suppose there might be multiplication principle. However, there is not for this one specifically. So we have something like in grade 3, our summer course have covered some of these. See, we have this example. I just put it on the screen. And do we have something else? You say for the hard problems, yes, you can help us. What about reinforcement, about some intermediate level? Well, you may memorize this weird factorial problem. Actually, we do have one in terms of our G4, grade 4 level course, and it's in ACE, of course. Spring, lecture 5, lesson 5, we do have such examples. Well, it might be a little challenging for our mastery or advanced courses, but don't worry, we'll cover that in the future. Definitely, we want everyone to have a chance to see what is going on here. So for this kind of analysis, in terms of n, in terms of 6, 5, 9, 12, don't worry, we have that covered. Well, back to the main topic. Because this time we want to discuss more about math study and the challenging questions. We want to see if we can tackle it. Well, now I have this question for you. Did you try the problem I said last time? Did you work on this homework? Well, this one refers to problem 22, which actually is a 3n plus 1 problem. Well, we introduced that before, so actually it is still open to mathematicians to study whether or not we have all such positive integers. If following this procedure, we have those numbers back to 1. Or you can think of that even further, like how many steps are they? Well, we know for odd numbers, they are supposed to get larger, but once they get larger, it becomes an even number, so it drops. But maybe at some point it goes back to an odd number that is not equal to 1, and then we bump it up again. So as at first, you can try 9. What did you try 9? We have this. That's what I did. So first we have 9 move up to 28, and then get back to 7, and then to 22, and back to 11, and going up and down, up and down, up and down. Although we have a very small start, that is 9. It's just the largest one-digit number, but it takes, how many steps are there? We have, well, I showed 20 numbers there, so let's say 19 steps to get to 1. Is it amazing? Well, 9 is not the most surprising number. Well, check with me if you have done it correctly, because the difficulty will get up. Now we have 27. Actually, the right answer is 111 steps. 27! Why? How come it is this large? Well, let's see. This is the whole procedure. Of course, if you look up the Wikipedia page, you will see this. This is the very example that we know it is super hard at a very small start. And, well, this is definitely the graph depicting it. So we have the number starting at a very low level, but then pump up, going up, down, and suddenly there's a number. Let me see, which one is that? We have very huge one. Oh, I missed an arrow there. It is supposed to be like 754. But we do have like thousands, around 10,000 there. It's super large. So sometimes math is fun. It's more like a game. However, if we extract what is lying behind, we can do a lot of analysis. Don't worry, we don't have 27 in this year AMC 8. We start from 1. We want to take back around like 6 steps. Later, I'll analyze how can we find it. In fact, if we know what are we doing, it is not hard. Good. Well, we have the warm-up. We have the warm-up, and now it is a core. It is a kernel for this webinar today. We'll move to the questions. Well, in the solution we provided, you will see we apply this analysis from complement. Of course, complement is always helpful. For example, if we have something in terms of at most or at least with respect to counting, maybe we can think of the other way. Right? For at least 1. That means the only exclusion or the only exception is that we don't have, or say we have 0 such cases. Then maybe it becomes easier because there are so many sub-cases. Maybe there's 1, there's 2, there's 3, or whatever. We want to combine all of these and sum over. And perhaps if for a complicated case, for a complex question, we may have them in terms of some weird expression or some strange numbers. However, if we think of the whole, perhaps there is a good structure. So we can know the total number easily, and then for a specific subcase, we can find that as well. And then we can take it from there. Well, we can do it here. For example, if we want silly and tiger, those 2 marbles are not next to each other. They are not neighbor to each other. That means there will be like 1 inside or 2 inside because there are 4 marbles. That means we have like 2 subcategories. Of course, we can do that. So I want to provide you 2 ways. One is by complement, and the other one, we want to do it directly. We want to get this brute force, or say straightforward analysis, to see how we can compare. Because sometimes there's no right or wrong decision in terms of counting, but it refers to fast or slow. Some are time consuming, some are time saving. We want to measure which one is the best for us, especially for a time limited contest. Well, for open questions, of course, you can do whatever, and the more ways you can think of, the better you are, the stronger you are, because you have so many tools to deal with this question. And in the future, maybe for an even more complicated question, there's exactly one of them applicable, and you know how many different ways you can try. Right? Thinking of a toolbox, I know a lot of teachers use this metaphor, a toolbox. If you have a lot of tools, and then eventually you know there's exactly one you can apply, just take it. Right, so here we have it. First, if we consider this by complement, any kind of permutation, if there's no limit, we know it is 4 times 3 times 2 times 1, which is 4 factorial. There are 24 such combinations. And what else? Well, we have specifically one restriction that we don't want those two to be next to each other. So how about we exclude all these cases? Well, if we have these 2 next to each other, that means we have this bundle method where, say, if we consider them as a whole thing. So if we have that, then first we have those 2 as a bundle, as a box, and then we have 2 other marbles. There we have a 3 factorial arrangement. And inside that box, still we have this order. We have 2 marbles. So we have a 2 factorial, or exactly just 2. We multiply those 2 together. We have 12. Exactly. Now we apply multiplication principle. First we assign these 3 objects, 2 marbles and a box. And inside we apply that, which is the next step. We have 2 ways. There we have 12, and then subtract 12 from 24. We have 12 as the final answer. However, that is the way of complement. What if I want to do it brute forcefully? I want to check, is that super hard? Or say, how can we find them? No missing, no repetition. That is our final goal. Can we? The answer is yes. And how? We have 2 subcases, and those 2 subcases are different, so we want to do it one by one. Right, so we have a case where we have 1 between, and we have another case which is 2 between. Well, we list all these. What does it mean for 1 between? That means we want to designate specifically 1 marble in between those 2. So the first 2 we have like 1 out of 2 for the other. We have Aggie, we have Bumblebee, so those 2 we can pick one of them to put it in that place, or say put it into that interval. All right, so now we have the first 2. What about the second 2? The second 2 we can determine what is the order of these 2, Steely and Tiger. So which one goes first, which one goes last. So we have these 2 permutations, or say 2 orderings. And what about the third 2? Right, think of this. Now we have 3 marbles put there. What about the fourth one? There's only 1 between. That means the fourth marble can either be in the very front or in the very end. 2 choices. So now, if we have 3 settled, and then we need to multiply another 2 to set it in. There we have 2 by 2 by 2, because we do each one as a step. So there we have exactly 8 ways, or say 8 arrangements. What about the other case? Well, now if we have exactly 2 between, that means Steely and Tiger are actually 1 in the front and 1 in the end. We don't know which is which, so we have a 2 there, just like what we did. And then in between, now it's very similar to our argument that for these 2, we have exactly 2 ways to put those there. So together we have 2 steps, then we have 2 times 2, where we have 4. And 8 plus 4, we have 12. Well, let me say here, see, you still do like 2 computations, but comparing to the first one, actually we have fewer. Well, that refers to this kind of comparison. What if it becomes more and more complicated? What if it becomes more and more complicated? Probably thinking of the complement is kind of easier. Or sometimes we want to have a combination for this and that. Alright, let's move on to see what is the next. Oh, yes, we have this number 3 question I mentioned last time. I really want to share about this. We have this flipping number. And it is in this format. So we want this more like zigzag, because we want not all same digits. That's why we don't consider 3883 as such. And now we have a 5-digit flipping number. Tell me, how can we represent that? Because we want to study it. And for number 3 questions, usually we want an algebraic expression. Well, if you use A and B, you get the same thing as what I did. Well, if you use X and Y, that's also perfect. That also works. Don't worry. So first, we set it in terms of this A, B, A, B, A, this representation, because first it is 5-digit, and moreover, we want that to be flippy. So the first digit, the third digit, and the 5th digit, all of these are supposed to be the same. And then the second digit and the 4th digit, those 2 are supposed to be the same as well. So we use two different numbers there. And to be super careful, don't follow me like that, we still need to know that A and B are different because we have distinct digits. Well, if it is divisible by 15, we need to separate down. We need to split up. And as always, we do this. 15 is not a prime, so 15 is 3 times 5. That means it has to be divisible by 3 first and then divisible by 5, or we can flip it over. I did the other way. So first, if it is divisible by 5, then first we know what? We have A equal to 0 or 5. Consider the last digit, right? Divisible by 5, we know the rule. The last digit, the unit digit, has to be 0 or 5, and since A also represents the first digit, the leading digit, it cannot be 0. Otherwise, it doesn't make sense here. So what? We have 5. A equal to 5, definitely. And what's next? Well, it looks like divisibility by 5 goes first, makes things easier. What about 3? Well, now divisible by 3, recall we have the rule. Add up the digits, the sum of digits. Then we can consider the divisibility of that sum by 3. So we can do that again and again and again. If that number is kind of larger, we can still reduce it, because we can recover it again and again and again. Now we have 3 such A's and 2 such B's. That means no matter what kind of A we pick, actually it doesn't change the result. So if it is divisible by 3, that means B has to be divisible by 3. Perfect. I know you can get it. So if we have 3 dividing B, 3 divides B, then all such cases for B are actually 0, 3, 6, and 9. Why I stopped there? Because B has to be a digit. We couldn't have negative numbers or numbers larger than 10. That doesn't make sense. Now we can check. A and B, they're supposed to be different. Well, 5 is not one of them, so we don't need to worry about it. However, still you need to check about it. In the future, for example, sometimes when we play with the signs, like positive numbers and negative numbers, it is very likely that sometimes we miss any of those. And about 0, of course. And then, consider all those combinations. We apply multiplication principle. Well, the number of ways we pick A and the number of ways we pick B, because now they are kind of independent. And there's only 1 for A and 4 for B, so together we have 4 numbers. And if you really like, you can check those. I put them down. We have 50505, 53535, and keep going. We have those 4 numbers. They're lovely. Although, first we think of that number to be super large, like the counts, but actually there's no such big number. Is that cool? Well, let's move to another one. Well, 20, I like it as well. Well, let me pause here for a second. Last time I put the QR code on the upper right corner. Later, I was told that actually my face was covering that. So this time I put it down to the lower left corner and it is on the top of my slide. So if you have any time, take up your phone and scan it. It is a WeChat QR code for our director. Tell him you're interested in our AMC 10 course, or if you haven't done so, you can register AMC 10 with us, as well as our MCTP course assessment as well. Well, we have all this kind of questions discovered. And now, back to number 20. This one, originally, it sounds a little bit weird. What does it mean? This kind of table. Actually, it is not a table. It is just a piece of note, a piece of paper. And I do like this. The setting. We have like 5 trees for the study, and some numbers were missing. Can we recover all of these? Well, I thought about that for a moment. Well, we do need to take out all this information. For example, the first line, it tells us that all of these individual measures are actually integers. Although for the average, It is very unlikely to be an integer. It's rare. But for the setting, all those trees, individual trees, we have integer heights, which is a good thing. And what else? All of these subsequent numbers are actually double or half of the previous one. So we do have some kind of relation in between. Does it sound like 3n plus 1? Somehow, we may have kind of a relation. So see, we have math game all the way, everywhere. And here, if we have tree 2 to be 11, what kind of numbers can we have for tree 1 and or tree 3? Because they're symmetric. We don't care if it's in the front or in the back, because we have that double in half. We can switch over. Well, given that to be integers, actually we know it has to be 22, because half of 11 is not an integer, 5.5. So immediately we know tree 1 and tree 3, all of both these two trees are actually 22. We have 22 meters there. And for tree 4, we need to be a little careful. That's how it becomes tricky, because we want to argue whether or not it has 11 or 44. Because for 22, it can go up or down. If it goes down, we have 11. If it goes up, we have 44. Which one makes sense? Well, if we don't know which one to go, we split it up. We have casework. And for 11, then we will get back to tree 5, which is another 22. We check it. Well, that doesn't make sense. The average is kind of small. Well, this is a trick. This is a trick. We don't really need to check about the ending digit versus the 10th digit there, because the average is kind of smaller than 20, and if you look up all these 5 choices, there's no such. It's a secret. I checked it with the selections, with the choices there. Well, after that, we know tree 4 cannot be 11. It has to be 44, and things are similar. That still we have 22 or 88 as 2 different choices with respect to tree 5. Well, 88 sounds incredible. It's crazy, but still numerically we want to check that. Well, we apply the same analysis. Like if we have 22 or 88, just plug those in. What is the ending digit? In fact, we don't know what happens in the front. If you do want to do all the calculation that's acceptable, you can do it. However, it's time consuming. The fastest way is more like checking the 10th digit. Because one is 2 and the other one is 8. Dividing 5, they're different. And then if we check it, we have like, say, we have 2. The ending digits are like 2 plus 1 plus 2 plus 4 plus 2. Taking the average, we will have 0.2. Whoa, that's a yes. And for 8, we don't have it. It's a 0.4. So then we know the last one must be 22, and then the rest will be counting all of these, which we don't need to add up all the test digits for the other case. Does it sound good? Well, every time, not only we're looking for how we find a way that works, but also we want to find a faster way. Which one is either? All right, next one. 22. Yeah, here comes the 3n plus 1 question. Well, the way we want to get it back is we do step-by-step analysis. In which direction? We know nothing about n. So if we want to split from there, oh gosh, that's really crazy. If n is odd, multiplied by 3, add 1, and then, of course, that is an even number, but we don't know what is that after dividing a 2. So, how about we get it back? If we have 1 as a final destination, can we recover this whole process? Well, definitely we know there should be different branches, because otherwise we couldn't cover all of these positive integers. See, when we study it, we know when we get it backward. This reverse analysis, there are so many n's. That's why it asks for the sum of all such integers. So we have a lot of hints, even from the language, from the literature. Well, first we can see something. If we have 1, we have to have the previous one to be 2, divided by 2. Because if we have 3n plus 1, then that n has to be 0, which doesn't make sense. We want to play with only positive integers. And similarly, if we have 2, we want to recover it back to 4, because it's not in 3n plus 1 format. So the very first step is straightforward. If we want to recover it, we compare whether or not we want to take n or 1, and then we decide we want to take 1, and now we get to 4. What's next? However, 4 is in the format of 3n plus 1, so 4 can be a half of a number, which is 8. We put it on the right-hand side. And what about left-hand side? 4 is equal to 3 times 1 plus 1. It is in a 3n plus 1 format, so we can recover it back to 1. See, now we apply casework again. And for that, we can have like 1, 2, 4, another 3 digits determined. And similarly, in fact, if we know 4 can get back to 1 or 8, then now if we have that part where I put A4 there, you will have around 2 different ends, either 1 or 8. Well, now our focus will be, what if I have 8 already there? Well, definitely we couldn't have 1 in the front. The question is, if we have 8, can we have that in terms of 3n plus 1? No, that n is not integer, so 8 can refer to 16 only. And back to 16, what's in the front? Well, 16 is in 3n plus 1 format. 3n plus 1, then that n is equal to 5. So either 5 or double it, we have 32. Again, we have 2 sub cases. And if we have 5, then when we have 32. 32 is also not in 3n plus 1, so we get it back to 64, and it's done. So we have only 4 n's. Well, this question refers to that game, but that doesn't mean it is perfectly this game, because you see, if we have, for example, 1 as a start or 8 as a start, actually we should call it an n for that n, 1. However, we just put it in and get back the output. But still, it refers to this kind of background. So seeing a lot will help us knowing what is going on here. Next. Well, this is potentially the last question I want to talk about today, because otherwise we will have so many questions. Well, for this one, what is your idea? What is your idea? Well, sometimes we need to distinguish whether or not we want to talk about the order or not, because we have 5 different awards and we want to assign those to students. So it looks like we have, say, A, B, C, D, E. Assigning A, B to the student is different from assigning C, D to the student. Not to mention, assigning A versus assigning AB to the student are also different as well. So now, we want to think of this. How can we split it up? First, we have this restriction. We want at least 1 award is given towards each student, towards the average student receives at least 1. That means at least 3 are assigned in this way. So we have 2 more. These 2 you can assign to 2 different students, where we have 1, 2, 2 assignment, or 2 to 1. That doesn't really matter. Or you can give these 2 awards to 1 specific student. So we have 1, 1, 3, or 3, 1, 1. There we have 2 different cases. That is the starting point. Like, what does it say? What is circumstance? What is the setting? We now have 2 subcases, and now we want to play with each and every one. We want to play with each single case. For 3 plus 1 plus 1, it looks like those 2 awards are not distinguishable at this point, although we know they are kind of different. Now we have 5 choose 3 to determine which 3 are put into that group, put into that bag. Why we use combination numbers? Because assigning to this student, I don't really care if he receives A, B, C, or C, B, A, or whichever combination. So in fact, they are all the same. That's the reason we pick combination. And then, what's next? Well, it looks like the remaining two are still different. So now, if we have 3 boxes versus 3 bags, putting there, the order of students picking all this are a problem. Because otherwise, we couldn't determine different cases. We couldn't tell one from the other. That's why we want to multiply 3 factorial, 3 times 2 times 1. So the first bag there should be 3 students, 1 out of 3 to pick it, and then the second bag there will be 1 out of the remaining 2, and then will be 1 for the last. There we have 60. Well, now it becomes a little tricky for that 2-to-1 assignment. Well, we can follow the procedure to put all of these into the bags, for sure. But then, think of this. If we have A, B, and C, D in 2 bags already, and now I have student 1 picking this and student 2 picking that, that is fine. But if I put all 3 bags there in some kind of order, like what if I have C, D in the front and student 2 pick that here? Well, when we have 3 students picking the first bag, that will double count if we have 1, 2 here, and then student 1 pick it. So to offset this double counting issue, we can think of like when we have A, B, and C, D, we always put 1 in the front, whereas the order does matter with respect to those 2 bags. Then we divide it by 2 to offset this, so that I always have a student picking the 1 in the front. So that's 3 ways, and then 2 ways to pick the second bag. So we offset that with respect to the bags, because those 2 bags are indifferent at this moment. To be super, super careful. I try to explain that to myself if we want to offset this effect with respect to students, but that doesn't make very good sense. So what does it mean if we want to offset those 2 with respect to those 2 students? Well, that's why I came up with this in terms of bags. And now the rest will be adding those up because we have addition principle. Perfect. So now together we have 150. You may ask, can we apply the way of complement? Well, I didn't give it a try, but maybe that works. Well, now it is your turn to tell me. Is it kind of easier that we apply way of complement to find it? How does that sound? Because thinking of all these, we may have like 4 plus 1, 3 plus 2, a bunch of ways to assigning all these awards if not all of these students are getting at least 1 award. Or maybe 5 to just 1 student. Definitely that is unfair. I'll feel really sad if I don't have any of the award. So that's all for the analysis for this year. Maybe if you like, still we have further analysis and further sharing with respect to all of these. And a reiteration, if you take AMC 8 with us, if you register with Think Academy, you might be wondering what score do you have. Don't worry, we'll get that back to you as soon as possible. Typically, it will take up to 30 days for the workers, for the staff to collect it, but usually you will expect it to be kind of shorter in the time. So probably for a week or 2, maybe you can see it. So you will receive an email with respect to your individual scores as well as your achievements for awards along with that. So stay calm. It will come to you shortly. And what about next level? Well, we introduced that before. If you're a newcomer for AMC 8, definitely you can study for that, get into a higher level for AMC 8. And if you think you're doing very well, you want to move forward, don't worry, we still have our AMC 10 course. We have AMC 10 registration this year. And we have MCTP if you think you are super talented as well. And a brief introduction about AMC 10. Well, about all the specs we have introduced before, so you can refer to our first half if you kind of forget it. Don't worry, it's about like 75 minutes, 25 questions, but it comes with a penalty with respect to the scoring, and so the way we study mathematics. And be sure you can take a good note. Be sure you have all your drafts. Get your hands dirty. That's what I mentioned last time. And what is covered in our AMC 10 course and what is covered in AMC 10 test? We have usually a 4-topic split. We have algebra, we have geometry, we have number theory and combinatorics, of course. So if you can tell it is not combination, you're super good. Well, for all of these 4, we will have one individual class talking about it in our short-term course. So if you are kind of new to AMC 10, don't worry. You will have perhaps you will have a general view with respect to that. How does it sound? Well, if you want to ask me like how can we register for that, well, here's a brief introduction. So if you have your Think Academy app on your cell phone, follow that selected course. You will see we will have this upper school, senior high procedure. And I know some students may have this issue about the grade because it couldn't be that wide. Don't worry. If you really want to give it a try, contact us and we can help you with this tech issue to get rid of this restriction. How does that sound? Well, before we call it an end, before we blow the whistle for today, well, try follow us. So if you're interested in our AMC 10 contest registration, we will have the link for you. And if you're interested in our short-term course, as well as our MCTP course or the assessment, also we have the link. And we have it provided not only in the chat, but also in the intro. Tell us if you like it. And also we have this QR code on the lower left corner. That's our director, so scan it anytime. Also, we do have our YouTube channel. We have our Facebook channel, Facebook page. We have our contact email. So feel free to contact us, follow us, so that you can get up-to-date information all the time. By the way, we have more webinars coming. We have one more tomorrow, and we have something in the upcoming weeks. How does it sound? Well, this year we have AMC 8 completed. So let's start for the next year. Let's move on. Thank you.